Good morning and welcome to Race Industry Now, the weekly webinar series from EPARTRADE, presented to you by ARP, Performance Plus Global Logistics, PIC, Shop Monkey, and Fifth Third Bank Motorsports. This is episode 355, and we're going to be talking with PRC. Again, good morning. I'm Francisco Savignan, the founder and CEO of EPARTRADE, the global platform for the performance racing industry. Today, we're missing Judy. She is traveling, but we have our superstar host, three-time NASCAR crew chief champion, Mr. Jeff Hammond. Jeff, how are you doing today?
I'm doing great, Francis. It's good to see you. And yeah, we'll miss Judy today, but you know what? It's up to us to carry on till the Queen returns, you might say.
Exactly. So without further introduction, we're going to bring Chris and Wade. I'm delighted to have Chris from PRC with us today. I've worked with him for over 20 years, known him. I saw him build PRC from the ground up. So this is a wonderful opportunity to hear from him and from Wade. So Jeff, I think Chris is here. Wade is here as well. So we'll let you carry on.
Well, thank you very much. And yeah, good morning, Chris. How are you?
I'm doing great. How are you doing, Jeff?
I'm doing great. Good morning, Wade. Are you still muted, my friend?
Not
Wade?
now.
All right, there we go. All right. I need to make sure we touch all those bases. Chris, it's good to put a face with your voice. Good conversation this morning with you, and I found it very, I guess you might say, enlightening to understand where you came from before you got into this this business, this passion that you have fallen in love with as far as oil pumps are concerned. But you were a mechanic at one time, crew chief, and you know race cars inside and out, right?
Yes, yes, we're based out of Indianapolis, and that's kind of where I started in IndyCar racing, and a lot of the people here have their roots in that as well as Wade. Yeah, so we have made a lot of IndyCar parts over the years, a lot of racing parts in general, but now we're pretty much the market has driven us toward oil pumps, I guess, and we've kind of become experts at that, I guess, and become in many different series throughout the world. We're involved in the oil systems and engine parts. So yes.
Well, we see where you've wound up, but really, what brought you that way? I mean, because were you an engine builder back in the day? Or were you more of the mechanic, engineer type, for a while?
Yeah, well, I've been more on the chassis side for a long time. I was with my last job was with Menards, and I ran the IndyCar team. I was crew chief there before that. And we also had our own engine shop. So I had experience there, as well as we had a facility in England that designed and manufactured race engines. So that fell under my management. So kind of got a pretty wide expertise, I guess, or experience. And it's Wade, at this business was always a supplier to people that I worked for. So we knew each other well, and they were, when you needed something very accurate or top-notch part, this is where you came. So my ears perked up when the opportunity came around. So yeah.
Looks like it's worked out well for both of you. Wade, so you're the guy that's kind of like the designer, the engineer when it comes to these parts and pieces. And how long you been working in that area?
Quite some time. I was fortunate over the years as a young man and moving forward with the business to be around a lot of really smart, intelligent people. And I think of myself as a product of them more than anything of my own doing. But I've been, I started out fabricating as well. Well, not as well, but started out fabricating and machining. And then in the late 90s, when solid modeling became available to the common user in job shop technology, we jumped on that real quickly. And that's when we started to apply that to our engineering capabilities.
So, Chris, I mean, I see you got some examples of your company's work and everything right there in front of you. So why don't you walk us through, what's it like, when you start, a new project, because again, or let's just say that you are looking at somebody else's parts or piece and you decide, I can make that better. I can take and make it in my design. I mean, what leads you down what path?
Yeah, it depends. If it's something that we, like these two products here are our designs where we will, sell to the market. A lot of times a customer will come to us and want a specific design for their application. And a lot of, so that begins with just some basic information, what the series is, what is the packaging, what is their pressure flow targets, and then once we, how we're going to drive it, or like this one here is a for a sprint car, so it's driven off the cam, so that tells you how it's going to be running at 50%. So and then this one here is a dirt late model, and it's a pulley driven oil pump. So once we have some of that information, then we kind of then that gets handed over to Wade, and then he starts looking at it in more detail.
So when you look at something like this, Wade, and you're talking about looking at it in more detail, I mean, let's look at it for what it is. I mean, nowadays, at one time, the oil pump had to be attached to the engine. Today, with all the different variations and the applications and the things that go with it, it doesn't necessarily have to be attached directly to I should say, to the front of the engine. You guys have come up with ways to, use it in a lot of different capacities. But what as far as the oil lines, where the oil lines go and all the stuff that go into this thing, because Chris and I were talking this morning and I came up with what Jeff Hammond likes to use as certain analogies, which is I look at this oil pump just like I'd be looking at a heart in a human being, because without pumping the lifeblood of an engine, which is the oil, and keeping it, flowing like it needs to, it's not going to last very long. So there's not just the pump, it's the whole package. When you're doing something like this, I'm sure you got to factor it in, because I think Chris touched on it, your oil pressures, your oil flows, all the things that go into the total package, correct?
You bet. I think that's an accurate summation of what's going on. And our market has changed over the years. Everything's become a lot more accurate. The engine manufacturers are requiring a level of repeatability that is unmatched, which is one of the reasons we have our own pump dyno, so that we can make sure that every time a pump goes out the door, as far as pressures, flows at specific temperatures, that it performs. We even measure depression in our engine sim tank. And so we can tell them, and we can print off a dyno sheet for our customers, and they can have confidence that this one's going to bolt on just like the last one did. And we try not to be the guy that you can easily say, oh, there must be a problem with the oil pump. We try and allow them to put that out of their brain if they see something different. And I think it's helpful to them. And so, like Chris mentioned, a lot of what we do is driven by what our customers have shared with us about their engine application. And we could spend a whole session talking about that. But today, the engine customers are doing more with oil than they ever have in the past. When you think of oil, I think we all think of, like you said, the heart of the engine keeps that oil running through it, which really, we call that the friction that's caused when it's not there. We call it friction, but even when it is there, there's a level of surface tension. Because, for example, and I'm a simple guy, so I use simple analogies. You throw a bucket of oil up in your bucket of oil, you just dump it out and it falls to the ground pretty quickly. You dump it over my head and it takes quite a while to get over all those surfaces before it hits the ground. And that's because of the surface tension. And one of the things that we do when it comes to efficiency of an oil system is we consider all those areas where there's surface tension in an engine or friction. And there's a lot of them. And so the way you approach how it gets used in every area is vital in accordance with how efficient they want it to be. And I'll be honest, there are some of our customers that aren't as particular as others, but some of our customers today have this figured out to the nth degree. And they want everything. In fact, some of our customers, when they come to us, they've already figured out in accordance with all the data that they can gather off their sophisticated engine dynos about what they think they can get in power if we can provide a pump or a system that only costs X amount of power that would be parasited from the engine to function. And so, having said all that, where we generally start is we'll consider lubrication, windage, circulation, heat rejection, packaging, and duty cycles. And all those things have a huge amount to do with where you start. And so typically once we've made all those considerations and every one of those points makes a difference to everything that we do as far as the design process goes. But we take all those inputs that Chris talked about amongst others, and we'll start out generally on the pressure side. And did you have something you wanted to share or say? Oh, okay.
No, I'm good. I'm good
Okay.
right now. I got some questions coming for both of you in a second.
Oh, good, good. Well, if I get too laborious with my remarks, I'm sure Chris will take care of it probably. But if not, let me know. But
Hey, Wade, you weren't on our conversation this morning. Just remember something. The rest of these people that are watching right now, they're not out there. Just pretend it's just the three of us. And if we were having a conversation, how polite would we be if we had something we want to make a point on? If I wanted to interrupt you, whatever, if we were sitting around in your office right now, we were, sharing ideas back and forth. Would it be like a free for all, or would it be like, I'll raise my hand and I'll ask a question?
well, absolutely. But thinking back to those that I learned a lot from over the years, a lot of that probably couldn't be said with a lot of other people watching. Anyway.
Well, and the times have changed for sure.
It was definitely a different time.
That's for sure. So typically we'll start off with total oil flow and consider where do we need to start with as far as how much this pumping system needs to flow, at what pressure, at what RPM. And really your pressure pump is a pretty simple thing to configure. I mean, it can get sophisticated with some of the ways that some of these engine builders turn things on and off, which is really quite cool. But anyway, not to go down another rabbit hole there. But it's pretty simple. You have your idle RPM threshold, which is about as slow as it's going to turn. And an oil pump is dependent upon the RPM to supply X amount of pressure and flow. So we have to be able to get close on the flow recommendations and figure out, one, how fast can we turn it in accordance with the space that's available, or how it's being turned, whether it's being turned off a cam, off of a pulley, and all these things come into play. Do we have to put any kind of reduction system in to get to the speed that we need to be at? What do we have to do to get that pressure pump so that it'll provide enough pressure at a low RPM, an idle threshold, we call it. When we are able, through discussion with the engine builder, to figure out what that idle threshold is, then we move through their RPM band. And the next, if we can't target specific spots in between, the next thing we'll do is we'll say, what's your maximum RPM that you think you'll turn this? And what do you think you're going to need in the way of pressure and flow at that? And so then we'll size it appropriately so that we have just enough at the bottom so as to not waste anything or too much when we get up top. Chances are when we get to the top of the RPM threshold, we're probably going to have to bypass some oil. And we build several types of bypass systems here at PRC. And some are more efficient and more useful in some areas, some racing applications than others. And we won't get into that one either, but we'll make a choice on pressure pump sizing, and then we'll decide how much with the best size that we can possibly choose to not bypass or to bypass the least amount possible. Then we'll choose the bypass. And now we're ready to make other considerations as far as those other points that were brought up. This is probably a good time if you have some questions, or I can go on.
Well, I'll tell you right quick, we do have a question I want to make sure we get to, because again, you're going to explain this a little bit later on in the conversation, but I want everybody to know that if y'all give me a question, I'm reading them, and we may get to a point when we may answer 2 or 3 of them at one time. So everybody who's, like I say, listening right now and watching what's going on here today's webinar, that we're going to try to answer all questions. And if we can't get to them, there'll be an explanation for it and a place to call to get them answered. But Chris, real quick, I want to make sure that, the stuff you had in front of you, you talked about your 2 pumps, right, but you also have some parts and pieces there right in front of you. And I want to make sure we don't overlook those and how they may be relevant to what we're, talking about today.
Right. Our basic design in pretty much across all of our pump designs, we utilize a spur gear on the pressure section, which that would be these. And we have different sizes of those, and they're very efficient for pumping oil. So clean, clean oil, not on the scavenge side, but on the pressure side. Now, when you're on a dry sump pump, just for clarity, I guess, like this pump right here would be a 5-stage pump. So there'd be one pressure section and multiple scavenge sections. So this one has 4 scavenge sections, and it has 4 sets of scavenge rotors inside of it. We use a helical style rotor that is very efficient at pulling air and oil. So when you're trying to evacuate the oil out of the crankcase or the valve train, you've got a mix of air and oil there. So helical rotors are really efficient at doing that, and better than gears or other things. So the uniqueness about ours is the tolerances are so tight in the design of them, they can self-dry. So if you could have like 4 stages, and you could have one side driving the other side on these without a separate gear to time those. So that's kind of unique to our pump. We've kind of figured out, or Wade's done a fantastic job at designing these things to where they are capable of doing that, that's just extra work you're not doing. So like I said, we have different sizes. These are a set of rotors. It's, you look at the size of those things, they're tiny, but it depends on the application. So there's applications that's a good fit for, and there's applications like these are the size that would be in one of these, where they're an aluminum block. They're really leaky, so you need swept volume. You need a lot of capacity to pull out the air and oil. But then once you get it out, you got to do something with it. So and then you got to remove the air from the oil. So Does that answer some of your questions?
No,
There.
see, that helps me out right there because I think it's going to help Wade, because here, this is the question that Michael Colburn has asked, is how do you deal with aeration and cavitation in oil? And you've touched on that with your design. And then I think, you know, that Wade probably can even explain that even more so. But I know that's a big deal with anybody that deals with dry sump pumps, as scavenging and what do you need to have that to get the right kind of pressure, like you're saying there, but you also got to extract the oil and the air together and do something with it. I mean, there's an art to it.
Yeah, and Wade, maybe you could speak to, like, you know, the options of like an air oil separator, and then also like what a proper tank is, you know, and those are things we do also. I don't have any of that here to show you, but those are things that we can do. So maybe Wade, you could speak to those.
Okay. Well, when it comes to aeration, that's certainly an evil when it comes to engine oil. One of the things it does is it carries heat. So one of the things we rely on the oil to do is carry heat away from the engine, but you allow it to get aerated, and it actually doesn't do that as efficiently. And there's several ways we can address that. One of the things we like about our helical scavenge rotors is they do not have like a straight rotor or gear. There's never a moment in time through the circulation of the rotors moving together that it has a linear leak where it all of a sudden isn't pumping and then it is again at 90 degrees. With any type of a straight device, you always have that. And it actually will cause a little bit of aeration. So one of the things we do with our pumps is use our rotors, and that helps with aeration coming straight out of the sump. Another thing that we find very helpful, but not necessarily necessary, as Chris mentioned, an air oil separator. We make those for our pumps as well. In situations where oil density is getting to a point where a customer is concerned about it, we can employ that on the back of the scavenge manifold at the rear of the pump or at the front of the pump, it doesn't matter. But we can actually take, and through a centrifugal process, we can do further separation of the air and the oil mechanically with, like I say, a centrifugal process. They call it an OAS, or an oil air separator. Now, what most people will do for to address aeration is they'll deal with it in the tank. And the easiest way to deal with it is just to make huge tanks. And the thought process behind that is that there's enough oil in that tank, in the bottom of the tank, that you'll get enough of it'll be degassed before what's being picked up at the bottom of it goes back through the engine. But in an engine that you're having that kind of a problem with, you're probably circulating a fair amount of oil. And instead of being at a 6 or 7 gallon a minute operating level, you might be at a 12 or 13 or 16 gallon a minute operating level. If you take 16 gallons per minute through that oil tank, how much time does it really have for there to be any kind of a settling degassing opportunity? There really isn't one. And so that can become an issue because we can't always put huge tanks, and I'm not a big advocate of it anyway. I think proper made tanks with an appropriate air oil separation device inside the tank will do way more for you than using a round tank and using the outside of the tank as that air oil separation device. If you think about it for a minute, if you send oil into one side of the tank, even if it's round, if it's 6 to 8 to 10 inches in diameter, by the time that gets 180 degrees around the tank, it's already going pretty slow. But if you force that into a tank that's only 2 inches in diameter, that's going to spin it around quite a bit. And it'll give the air an opportunity to say, hey, I'm going to take the path of least resistance. which, if you build your swirl pot correctly, will be out the top of the swirl pot into the vent chamber. So if you employ a proper swirl pots and vent chambers in your tanks, it doesn't even matter what the shape of the tank is. And you'll find a lot of your bespoke engines have a lot of the tanks stuck right to the front of the engine. And that makes so much sense because you don't have line length. And remember, we talked about pouring oil over us. Doesn't matter how good your pump is at sucking or pushing. If you got these long lines, you still have that surface tension on the oil, if that makes any sense as you move it. And so that's doing a lot to inhibit the efficiency of your system. So cavitation is another thing that is exacerbated by aeration. So they kind of go along with one another. But one of the things, and one of the groups you had on here a couple of weeks ago did a good job of describing that. I think it was the gentleman from Peterson. And he accurately spoke about what cavitation is. So I won't get into that again because he can go back to that. But where you'll find it the most is when you have areas that are disturbed in their flow. So if you have a 90-degree line with a sharp edge in it, you get a little vortice created, and you'll get the oil, instead of making a smooth turn and changing direction, there will be a little section where that vortice is created, and those little vortices are not good. And on the outlet of a pump, it can actually cavitate. It can do a little bit of damage. And it also inhibits, the actual scab flow. So once again, keeping your line length short, keeping any sharp turns, billet stuff's great. But even we over the years have made some mistakes of using billet areas in a sump, because we build billet sumps, and intersecting those when they had to go 90 degrees with a fitting that had a sharper edge on it. And when you do that, you get the job done. But if that's on a supply line, that can be quite detrimental to your supply oil. And you might find that you're struggling on that. You might think of all these other reasons that are causing your problem when it's that one sharp edge. So I hope that helps with the gentleman that asked those questions.
Well, I think we'll get a little bit probably feedback from that as we progress here, but we do have a couple of more follow-up questions. And Austin Snyder would like to know, what is the target design volumetric efficiency of the scavenge section, and how is this evaluated on a test bench or on an engine? And then I'm going to do a little bit of follow-up because we were talking about air releases and stuff here. Michael Colburn did a follow-up question because he was the one about cavitation and aeration. Is that what if the air release properties of the oil could be improved? Would that help, with that, some of that air that's being created by the oil being circulated?
Absolutely. If you can do anything to help minimize any error that is reintroduced by those types of situations, is going to be helpful to your volumetric efficiency. And when we start talking about the efficiency of pumps, it's kind of an interesting thing, because like Chris mentioned earlier, you have the engine, and in the oil pump business we call the engine the leak. Okay, and then you pull from the leak, and then you send it out. And at the end of the day, your efficiency a lot of times is dependent upon what you have to pull from. Does that make any sense?
Yeah, it does to me.
That's where oil pans come into play. And they're huge when it comes into this, because, and this is where I hate it when people say, well, will your pump make some horsepower for me? And one of the things that we always try and help them realize is, hey, your engine makes all the power. Now, some of the things that our oil pump will do for a very efficient amount of cost of power can help recognize some of that power you're already making at the end of the crankshaft. And that's our goal. And with windage, and aeration, that's where we can make some big gains in helping engine builders to recognize more power that they've already made. And the way that works is part of that is in the pan construction. Part of that is where overhead oil gets introduced, because at the end of the day, you want that crankshaft turning as free from oil as you possibly can. And how difficult can that be if you got two banks of piston oilers? If you've got drain backs coming in from the heads and other overhead stations into the crankcase. Now, a lot of your engine builders have gotten pretty cagey about how they do that. They'll take their overhead drain backs and send them to an actual scavenge pump, and it never sees the crankcase, and that's optimal. And then on the crankcase side, the best thing we can do is have pumps that are efficient enough at pumping air and oil that we can pull best negative crankcase pressure in the sump. And but we can't do that until the engine builder has got the leak under control to a certain degree. So that takes into consideration seal technology, and it also takes into consideration blow-by and how much oil they're actually sending into the main line to do its job on the bearings. When they've done all of their work the best that they can, which most of them do a great job at that, and our pumps can make a lot of vacuum. We say that sometimes that, our products sometimes really suck, but that's a compliment.
Yeah.
And so it's hard for me to say when someone calls me and they say, hey, I've got this V8, whatever it is, or I've got an inline 4 turbo, whatever it is. And the first question out of their mouth is, how much vacuum can you make with that? We have to go back to those questions that Chris talked about originally, that he will generally go through with a customer to find out what they're set up for to be able to do that. Because if they don't have proper seals, we can pull enough vacuum that we start pulling air, atmospheric air into the sump. And that can actually make things worse.
Yeah.
So anyway, I hope that was helpful.
Well, it is for me. I mean, because again, I understand. I guess, here again, Chris and I were talking old school stuff. When you go back and everybody originally started with, wet sump pans, and what we were doing with it, and all the technology that is, and the sciencing out everything since then. And you brought in pans, and you talk about the tank. And I mean, this is a huge process, but it's like the way you make power is not to give it away. I mean, you make it, but at the same time, you got to make sure you protect it. And there's a lot of things you can do with the oiling system that can, assist in that maximum number, that maximum torque and horsepower number that everybody's shooting for. But if it's not properly all put together, once again, use the analogy of the heart versus the human body. If you got a restriction, if you got something that's not flowing properly, it affects the whole body. It affects everything. I mean, the end game begins with the proper configuration of all the above. Your pump, the oil lines, the tank, they all work hand in hand. The oil itself, and then also, like you say, it goes back to the construction of the engine. If there's something that's not put together properly there, now you got problems. I mean, you got concerns. I mean, and this is what happens, I think, with a lot of engine people. They get experimenting, and they make a mistake somewhere. And I'm not. That's what they're supposed to do. So don't get me wrong when I say they make mistakes. They do make mistakes, but they're experimenting. I can't tell you how many times I've watched Junior Johnson destroy a block, try to figure out how we can either get some oil to pass through someplace to try to do something that hadn't done before. I mean, and it's that type of technology, that type of desire to make an engine better and perform better. They all go hand in hand. I mean, that's the reason why you guys are what you are today. I mean, it's not just give me a oil pump and I'll put it on there and walk away. You come with the total package. Call us. We'll help you design it. I mean, I love what Chris was saying. You know, we're in the business to help. We will work tirelessly to make sure that happens. And excuse me, but that is what I think anybody that's in a racing world, that's what you're looking for. I'm looking for a partner. I'm looking for somebody who has an interest. And you opened and talked about at the very beginning about being able to ship your product to an engine builder and bolt it on there without somebody having to take it back apart or run it onto their dyno to verify that what they've got is what they've got. You guys are building a trust factor and a confidence that repeatability, durability will wind up being competitive, give you a competitive edge against your people, in which bottom line, that's usually equals out to profitability. You know what I'm saying? It all goes together. It's a big package.
Absolutely. And I think that's been beneficial to us as we've built so many different types of parts to be able to do packages, and or if they only need a pump, we can do just a pump. But either way, we're always here to be helpful if we can. On the front side of it is they make considerations about the package. And even if they don't need us for the whole package, we're glad to help them with part of it. And on the note of volumetric efficiency that one of your gentlemen asked too, one of the things that's really I love about our rotors is they're two lobe rotors. And Chris mentioned also, not only are they two lobe, but you put just a few sets of them together, they can also be self-driving, which allows our engine builders to put the scav pump on one side of the engine, which is best for it to be. And if they want to put the pressure pump on the other side of the engine, they have that opportunity. And they don't have to be mated to be able to function appropriately. And but going along with that, not only are those scav rotors efficient, but with the dual rotors, we carry a lot more swept volume than a tri-lobe or a quad lobe, because they're filling that area in the pump well with rotor instead of air and oil, if that makes any sense. Our pressure gears are the same way. We use different amounts of teeth and pressure angles that allow us to have more swept volume. So we have pump gears where we can take, and sometimes it makes our customers nervous, where they'll say, hey, I'm running 1.5 inch gear. I know I need at least that. And we'll say, probably, because I know the pump you're using, our 1 inch gear will be sufficient. And they don't want to hear it. So I'll say, well, if you'd like, send us that. Send us your pump. I'll go ahead and if Chris is okay with it, and we'll digitize your pump gear, and I'll match the sweat volume for you to give you the confidence you need to use that 1 inch gear. And then they're generally okay with it. But, we try and spend a lot of time doing our homework on those types of things, because at the end of the day, packaging is huge. I'm sure when you got an engine, you wanted all these pumps and things to be almost non-existent because they just get in your way, right?
That's it.
And we've heard that for years. Make that thing smaller. I want to adjust my pickup points so that I can get appropriate chassis settings and have some opportunities to adjust things to go faster. And so that's why we have larger and smaller pumps. And, we can generally apply them in fairly equal ways as far as performance goes. But the smaller you go with things, you have to make other considerations, and that tends to be a little more expensive too. So anyway, I apologize if I'm rambling.
No, that's a very and it just makes me remember the times that I've been, because if you think about it, at one time, we didn't have the luxury that is present today. You got chassis from a chassis manufacturer. He built chassis. He didn't worry about engines. It's your problem to get the engine in my chassis and make it work. So it's like All right, that wasn't too bad in the very beginning because again, there's wet sump pans. No big deal. Just don't let it hit the ground. Then we get into dry sumps, and that opened up a whole new can of worms. I mean, so everything as we like we're saying has created the need to design and work together and realize, you know, nowadays we build everything in simulators, and you build the engine and you make sure it fits in the chassis you're building around the engine to a certain degree. But I like the idea that if we've got a problem or we got a thought process, whether we're running the Daytona 500 or whether we're running Pikes Peak or whether we're going to run the 24 Hours of Le Mans, we can come to your organization, tell you what we're going to do here, and this is what we're going to be running there and how we're going to do this. And I would feel like all of a sudden we got a communication and a level of confidence we're building between all of us that we can get this project to be successful. So
Yeah, and that's right. And we're more than willing to fill whatever role that is. If that's just a pump or if that's a complete, you know, engine kit with a oil pump, water pump, you know, covers and drive accessories and things. So, you know, whatever role that is that the customer wants, we're happy to do that. So to fill that role.
And based off of, I guess, y'all's your response, Michael Colburn sent back this a moment ago. So I think he was talking about the air release and then the oil itself, you know, not contributing to the air problem. So if you have less air and more oil to pump, that's a plus. And I would say absolutely, because there again, you're going to have the ability to cool oil and have everything stay more, I guess I would consider it less contaminated. You know, you're taking air out for a reason. You don't want oil going through there. I mean, you don't want air going through your bearings. You want oil going through your bearings. So all of that is a plus, correct?
Absolutely. There is, however, a time when you have to consider that you do have to have a certain amount of displacement value. If you take something away from something and you can't displace it with anything, then you can create a tremendous fight. Now, how much that is pretty insignificant, but you still have to keep that in mind.
Very good. Very good. So what else we got coming down the pike, Chris? I mean, here Francis is back, which is telling me that we're on a 2-minute time limit here. But what do you got coming down the pike as far as anything new and exciting as far as your company's concerned?
Well, I mean, definitely the dirt lake model is a new product that's taking off tremendously. We're pretty happy with it. We've been in the sprint car market for years and years. Of, you know, our customers have won many championships in that, and we're excited to be involved in the dirt late model series in the U.S. and that seems to be going very well. And we plan for to just we're building up inventory and to go after that market pretty strongly. So and then we're always looking for new projects, you know, so interesting things. So yeah, so.
Well, Francis, all I can say, you've known these gentlemen here, you said, for over 20 years. And since we opened this thing up as the analogy of having a heart and working on it and everything like that, I think I would recommend these two doctors. So if you have a need to work on your race car or make it perform a little bit better, I would call these gentlemen up. I think they can give you a solution to whatever kind of problem you have.
You're absolutely right. So thank you very much, Chris and Wade, for sharing, you know, so much expertise and you are what this industry is all about. You're innovators, you're racers, entrepreneurs, and no, thank you very much for being, you know, with us today. So this webinar has been recorded. It will be posted later on the EPARTRADE platform, distributed through our newsletters and social media channel. Don't forget to go on the EPARTRADE platform to check PRC's products. We push them back on the homepage. And next week webinar will be with Jito Tools. And for more updates and resources, please visit epartrade.com. Thank you once again and goodbye.
Thank you.
Bye-bye.
Thank you, gentlemen.
EPARTRADE is a digital platform that we've created basically to make life easier in the business community of auto racing.
EPARTRADE, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there, it is forwarded directly to the buyer or to the supplier.
EPARTRADE really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
With ShopMonkey, we've been able to grow the shop by 20% in gross sales since implementing it in the shop. Everything that we were doing before has been sped up with ShopMonkey. All of our parts ordering, all of our approvals, all of our mechanics knowing what to do next. And I've had friends that are in the trade that own shops ask about ShopMonkey, and I highly recommend it just because of easy use. There's nothing like it with that kind of platform.
With roots in the Midwest that date back well before the Model T, Fifth Third Bank has a long history of serving the needs of automotive companies. While much has changed over the years, our passion for helping businesses put cars on the road and on the track has not. Today, we are more committed than ever as a member of SEMA, a founding member of PRI, and a sponsor of multiple race teams across several racing series.
For over a decade, Fifth Third Bank has been a staunch supporter of our industry and a great partner for many companies in the motorsports field.
Our business has been growing extremely fast, and really we could not be where we are today without Fifth Third. They provided amazing strategic advice, the capital we need to support our phases of growth.
They are true partners for me now, and what they do with their involvement in motorsports is untouched in this community.
Where can we take your business? Fifth Third Bank.